This is the solution to example 4 from notes P.5. Here we're asked to asked to simplify a complex fraction, which is the numerator has fractions in it and the denominator also has fractions in it. So we're going to first do it by the method where we work with the numerator and denominator separately. So we're going to simplify the numerator by adding those or subtracting those fractions, and the same in the denominator. So in order to add or subtract fractions, we need a common denominator, and we need one for the numerator and one for the denominator. So let's work with the numerator. So we have 5 over y minus 6 over 2y plus 1. Here, the least common denominator is y times 2y plus 1. This is for the numerator. So we're going to multiply the first fraction by the factor from the common denominator that's missing in its denominator. So we're going to multiply the first fraction by 2y plus 1 over 2y plus 1. This is a funny form of 1. And the second fraction we're going to multiply by y over y. And then in the denominator, we need to do the same thing. So here, I'm going to rewrite this as 5 over y plus 4 over 1. The least common denominator here is y. So the first fraction has the least common denominator, but the second does not. So we need to multiply the second fraction by y over y. And now we're going to distribute in the numerator. So we'll distribute the 5 to the 2y and the 1. So we're going to get, in the numerator, 10y plus 5 over, I'm going to leave this in factored form, 2y plus 1 times y. And the reason to do that is some factors might cancel out. Minus 6y over 2y plus 1 times y. Now we have a common denominator in the numerator. And in the denominator, this is going to become 5 over y plus 4y over y. So now we can subtract the fractions in the numerator. So we have 10y plus 5 minus 6y gives us 4y plus 5 over 2y plus 1 times y. And the denominator, we have 5 plus 4y. I'm going to write this as 4y plus 5 over y. So now we have combined the fractions in the numerator and we combine the fractions in the denominator. We are ready to divide. So we are going to take the reciprocal of the denominator and multiply. So that will give us 4y plus 5 over the quantity 2y plus 1 times y times the reciprocal here, the denominator, which is y over 4y plus 5. And now we can cancel out common factors between the numerator and the denominator. So I can cancel out 4y plus 5, and I can also cancel out a y. When I cancel both of those factors out of the numerator, that leaves us with a 1. So the simplified expression is 1 over 2y plus 1, but we need to make sure that we exclude any values that made the factors from the denominator that we canceled out equal to 0. So what are those values? Well, 1 comes from y, which is just 0. And then the other value comes from the second factor that we canceled out, which is 4y plus 5. That can't be 0, so we could subtract 5 from both sides and then divide both sides of the equation by 4. So we'll have y is not equal to negative 5/4 or 0. So I'm going to actually put these in ascending order. So negative 5/4 or 0. We need to include that in the simplified expression because without it, our expression won't be correct. Because in the original expression, 5/4 and 0 made the denominator 0, so they're not part of the domain. And then if we want to state the entire domain, we have to exclude any value that made any of the denominators 0. So in addition, we need to exclude the value that makes 2y plus 1 equal to 0, because that factor is still remaining. So 2y plus 1 is not equal to 0, 2y is not equal to negative 1, and then divide by 2. Y is not equal to negative 1/2. So the domain is all real numbers except y is not equal to -5/4, -1/2, or 0. That is our domain. All right, now let's simplify this with the second method. And in the second method, we are just going to multiply the entire complex fraction by the least common denominator of all of the denominators. Okay, in the second method, we're going to multiply by the least common denominator of all the denominators to clear the fractions. So let's set that up. So we have 5 over y minus 6 over 2y plus 1 over 5 over y plus 4 over 1. The least common denominator of all these denominators is simply their product, which is y times 2y plus 1 over 1, y times 2y plus 1 over 1. I'm writing them in that form because we have fractions. And now we're going to distribute the y times 2y plus 1 to each of the fractions. So in the numerator, we're going to get 5y times 2y plus 1 over y. And then we're going to get minus 6y times the quantity 2y plus 1 over 2y plus 1. And then in the denominator, we're going to have 5 over y times 2y plus 1 minus 4 times y times the quantity 2y plus 1 over 1. And I need to scroll up a little bit. Okay, so now a nice thing's going to happen and a bunch of factors are going to cancel out. So in the first fraction, we can cancel out y. In the second fraction, in the numerator, we can cancel out 2y plus 1. In the first fraction in the denominator, we cancel out y. And the second fraction, the denominator, we just have a denominator of 1. So there's nothing to cancel out. So now all the fractions have been cleared. So in the numerator, it's 5 times the quantity 2y plus 1 minus 6y. In the denominator, it's 5 times the quantity 2y plus 1 minus 4y times the quantity 2y plus 1. Now let's combine like terms in the numerator. We'll distribute and combine like terms in the numerator. So that's going to give us 10y plus 5 minus 6y. The denominator I'm going to factor. That's going to give us 2y plus 1 times 5. Oh, this is a plus. I have the wrong thing. Plus 4y plus 5. I corrected. I dropped. This should be a plus sign in the denominator throughout. And then 10y plus 5 minus 6y gives us 4y plus 5 over 2y plus 1 times the quantity 4y plus 5. We can cancel out the 4y plus 5. That gives us 1 over 2y plus 1. And then we need to exclude any values that made the denominator 0 that we canceled out. So we have to go back to our work and see factors that we canceled out that are no longer in our expression. So we canceled out y here. And in our final expression, there's no y in the denominator. And while we canceled out a 2y plus 1 up here, we still have 2y plus 1 in our expression. So we don't need to account for y is not equal to -1/2 because we can see that from the 2y plus 1 factor we still have. But we did factor out a 4y plus 5 here. And the factor that makes that 0 is -5/4. So we need to list y is not equal to -5/4 or 0 from our simplified expression. And then the domain will be the same thing which we got last time, which was y is not equal to -5/4, -1/2, or 0.